All right, welcome everyone. Today we are going to move into calculating the surface area of cylinders. So a cylinder obviously has two round bases, circular bases, and then when we're looking at it, we're given the height normally. We're given the height normally whenever you look at the space between the two cylinders. So if the cylinder, or sorry, the space between the two circles. So if the cylinder is drawn like this, the height is still considered there. Okay, it's that space between the two cylinders that you're looking at. So when we're calculating the surface area of a cylinder, we need to find the area of the circular bases and as well as the area of the curved surfaces. Okay, so as we've reviewed already, to find the area of the circles, we use this formula of A equals pi r squared. And remember, r squared means that this is your base and this is your exponent, okay? So r squared doesn't mean r times 2, it means r times r. So we're going to multiply the radius by itself. Whenever we're doing that, we need to make sure, I've told you before, the common error that students make is that they do r times 2, or the radius times 2, and they just get the diameter, and that is not correct. So just a real quick review of how to find the area of circles. Okay, so we're going to do these ones, and remember that the area of a circle, the formula is area equals pi r squared. Okay, so in this case I already have my radius, so it's 8.7 squared. Okay, so I'm doing 8.7 times 8.7, so I get pi equals 75.68. Okay, sorry, 69. And then when I multiply pi by 75.69, I get my answer of 237.79. My unit of measure is going to be millimeters squared. In this next one, I first have to find the radius. So remember that radius is half of the diameter. Okay, so if I do 5.2 divided by 2, I'm going to get 2.6 centimeters. And then I use my formula for area of pi r squared, 2.6 squared. Now here's a case where you can see it. If I were just to do 2.6 times 2, what I would get is that 5.2 again, but that is incorrect. So when I square 2.6, I actually get 6.76. When I do that correctly and I find the square of 2.6, I get 6.76. And then when I multiply that by pi, I'm going to get 24.24 centimeters. And that kind of makes sense because this is almost 7 and this is almost 3, so it should be around 21, my answer. Once again, here in this last one, I've got the radius, so I don't need to do anything. I just do pi r squared, and I got 6.8 squared, and then I get pi times 46.24, which makes sense because 7 squared is 49, so that's pretty close, a little bit less. And then when I multiply 46.24 by pi, I get 35.27, and my measure is millimeters squared. So don't forget, though, that there are two circles in the cylinder. So that means when I'm calculating the surface area of the cylinder, I am going to be multiplying by 2, just like we did with the triangles and triangular prisms. Okay, so when we are then thinking about this net, we've already talked about how to make nets. Okay, so we have the two circular bases, and then we have the rectangular part, which is the curved. Okay, so to find the area of the curved surface, we must first remember that when we create a net of a cylinder, the curved surface becomes a rectangle. And remember, we're going to have this dimension. It's always going to give us, or it should usually, I shouldn't say always, but it should usually give us the height. Okay, now the thing about it is that when we put this together, as we saw, this is the same length as this. The circumference of that circle is the same length of the base or the width or whatever you want to call it of that rectangle, the missing measure of the rectangle. So that's what we need to keep in mind. So then if we calculate the circumference, there we go, of the circular base, we can find the length of the rectangle when we draw the net. Okay, and then we can use the given height of the cylinder to find the area of the rectangle. Okay, so when we're doing circumference, we remember that circumference is equal to 2 pi r, okay, which is this part of this formula I have in here. If you want to just do the like, if you're not drawing the net and you want to just do the height of, or sorry, the area of the rectangle, this formula of A equals h times 2 pi r, which is h times the circumference, will give you the area of that curved surface. You can always draw the net, but at a certain point you're going to want to be able to maybe just calculate it. So really quickly, we're going to review, we're going to use the same circles, but this time we're going to find their circumference. So we have circumference equals 2 pi r. Okay, and then we have 2 times pi times 8.7, and I gotta get my calculator here. So 2 times 8.7, remember we can do these in any order. We get 17.4 times pi, and if I multiply that by pi, I get an answer that rounds to 54.66, and that's just millimeters. Remember, it's a straight line that we're measuring, so we're not actually going to measure it in centimeters squared or millimeters squared or anything. It's going to just be in that unit. Okay, we already found that the radius of this was 2.6, so we're going to go C equals 2 pi r. C equals 2 times pi times 2.6. We know that 2.6 times 2 is going to give us 5.2. So 5.2 times pi gives us 16.34 centimeters. Okay, and then again we have C equals 2 pi r equals 2 times pi times 6.8. 6.8 is going to, times 2 is going to give me 13.6 pi. It's 13.6 times pi is 42.73. And then again, my measure is millimeters. So if we put the two calculations together, Mr. Mackenzie didn't proofread, so that should say put the two calculations together, we get the following formula. If you did not want to calculate the or draw the net and do each thing individually, you could use this area formula. I still find it easier to do it as its own little as each part individually. So I like to draw the net with cylinders because I find cylinders a little bit more challenging, and so I like to draw the net because the net's super simple to draw too. So then we're going to practice as always, okay? And I am going to draw the net to start. So the measurements here are that and that. I'm going to show you the first one, and then we'll stop the video and you guys can work on the second two on your own, and then we'll go through it again. So again, really simple net here, rectangle to represent the curved surface, and then we have two circles. Okay, how do we label this? Well, we're going to have A and B. Okay, says my radius is 1.75, so I'm going to draw a line with my radius. I'm just going to put it out here because it's a little bit smaller. And then my height is 3.6. So the first thing I need to do is find the circumference, right? So I'm going to go 2 times pi times r, 2 times pi times 1.75, which is 2 times 1.75 gives me 3.5 times pi. And just take half a second to throw that into your calculator, and you'll see that it's I think it's like 10.995. So we're just going to call that 11 because that's actually what it rounds to. So it's 11 centimeters. I'm then going to take that measurement and put it on my rectangle so I know what my measurements are. Okay. And then I'm going to start with the area of A. So we have two circles and we're going to multiply them by pi r squared. That's the formula for area. And we have two of them. So that's why we do 2 times pi times r squared. 2 times pi r squared. We have to start with what's in the brackets and we start with the exponent. So I keep that 2. My radius is 1.75 squared. So I'm going to start with with this. Okay, so I am going to go back to blue here. 2 times pi and 1.75 squared rounds to 3.06 when you multiply those together. I'm just going to double check that. Squared, yeah, 3.06. And then when I multiply that by pi, 3 times 3 is 9, so I'm going to get something around 9. So I get 9.62, and that is, when I multiply those together, I end up getting 19.24 centimeters squared because it's the area of the circles. Then my area for B, which is my rectangle, is just base times height. And my base is 11 centimeters and my height is 3.6 centimeters. So when I multiply the two of those together, I get 39.6 centimeters squared. And then simply enough, I add those together, 39.6. Remember, you have to show this as a separate calculation that you're adding these together. I want to see this as a separate calculation. I'm going to throw 0 in there just so that they have the same number of decimal places. The 0 doesn't change what that number is. So 0 plus 4 is 4. 8, keep my decimal consistent. That's 18, so that's going to give me 58.84 centimeters squared. So the steps are really not all that more challenging than rectangles or triangular prisms. The difference is that we just have to do maybe one more step with the circumference to find the length of the rectangle, and then the formula for circles is different. So what I want you to do now is pause it. The teacher can pause it, or you can pause it if you're watching this on your own, and then spend about 5 to 10 minutes working on the next one. And then once everybody's done that second example, I will work through it so you can replay the video, and then we'll pause it again and do the last one. Okay, so you've done this one, or you should have done this one. I'm going to draw real quick again my net because I like to do that. I have a height of 2.6 nanometers here, and then radius. I didn't calculate the radius yet, so I'm going to do that real quick. Radius equals diameter divided by 2. 3.9 divided by 2 is going to give me 1.95 nanometers. So 1.95, and then I'm going to have A, and B. And then to get that other area, the circumference, right? Because this line here and the circumference of this circle are the same. So we're going to do, I'm going to switch up the colors here. 2 pi r is the formula for circumference, and 2 pi times 1.95, 3.9 pi. So I have 4, and the value of pi is I have about 4 here, and the value of pi is 3, so it's going to be about 12, maybe a little bit more. And when I throw that into my calculator, it is a little bit more, 12.25 nanometers. So then I'm going to go area of A. Remember, I have two circles, and the formula for circle is pi r squared. and I have 1.95 squared. Remember, 1.95 squared does not mean multiply by 2. You're multiplying 1.95 by itself. It's very different. So when you do that, you get 3.8. And then when I multiply the pi by the 3.8, I get 11.94. And then when I multiply that by 2, I get 23.88 nanometers, and it's squared. Okay, and then my area, oh, I forgot to throw my area in my drawing, 12.25 nanometers. Okay, area of B is base times height, so I get 2.6 times 12.25, and that's going to give me 31.85 nanometers squared. And then my last step, I'm just going to move this over just a little bit so I have a little bit more room, is to add those two together. So 31.85 plus 23.88. So 5 and 8 give me 3. Add one up there, 1, 8, 9. 1 plus 8 is 9, plus 8 is 17. 1 and 1 is 2, plus 3 is 5, and 5. So I get 5573 nanometers squared. And that is my area for that one. So again, pause the video, 5 minutes to do the last one. The last one's fairly simple. All right, once again, just real quick, I'm going to draw this one just a little bit differently. There, there, and there. That's my net. I got A and A. My diameter is 4. You guys should be able to do that mental math fairly easily. So our radius is 2. And then my height is 5.8 centimeters. So when we go C equals 2 pi r, we get 2 times pi times 2, 4 pi. Again, 4 times 3 is 12, so this should be just slightly more than 12. And it is, it's 12.57 centimeters. So that's the missing measure of my rectangle. And then I'm just going to go area of A is equal to 2, because I got 2 circles. Formula for the area of a circle is pi r squared. 2 squared. Now remember, 2 squared is the only case where 2 times the exponent, or the base times the exponent, is going to give you the same thing as the base times the base. So it's one of those confusing ones, but we're going to get pi r. So we already know that pi r is 12.57, and when I multiply that by 2, I get 25.14 centimeters squared. Then I'm going to go area of B, which is my rectangle, base times height. We should be good at that by now. We got 5.8 times 12.57. When I multiply the two of those, we're looking at 72.91 centimeters squared as our answer. And then don't ever forget to add the two of them together. So many times I've seen students do all that work and then miss the easiest step of adding them together. So we got 5 there, don't have anything to take over. We got 0 there. 1 and 5 is 6, plus 2 is 8. So we get 98.05 centimeters squared. Now you're going to do some practice problems from your book, but that is basically it. Fairly simple, fairly straightforward, just new formulas to work with. Thanks, everyone.